Hello everyone. Today we are going to discuss JEE 2022 paper of 25th June, Shift 1, Chemistry part. In which of the following species bond order increases after removing one electron? So let's check one by one. First we have B2. Total number of electron in B2 is 10 electron. So bond order is equal to 1. Okay, after removing electron, it will be B2 plus, and now it will have 9 electron, then bond order will become 0.5. Okay, so bond order is not increasing. Now let's see the next one, O2. Total electron is 16 electron and bond order is equal to 2. After removing electron, it will become O2 plus, that is 15 electron, and now the bond order will be equal to 2.5. So now bond order is increasing in the case of O2. Okay, let's check the another one. N2, it is total of 14 electron, so bond order is equal to 3. After removing electron, it will become N2 plus. Now it is 15 electron, so bond order is becoming 2.5. So again in this case it is decreasing. And the last one, NO. NO is total of, it is NO plus. Wait a second, NO plus. NO plus, total electron is basically 14 electron and the bond order is 3. Now after removing electron, it will become NO2 plus, that will have now 13 electron only, and the bond order will become equal to 2.5. So for the first one, bond order increases after removing one electron will be from O2. Okay. Now the next one. That question is directly based on what? The preparation of phenol and in phenol, the industrial method. We have cumene basically. This one is cumene. Cumene is undergoing oxidation, forming cumene hydroperoxide. This is cumene hydroperoxide. And the hydrolysis of cumene hydroperoxide basically gives us phenol and acetone. Phenol and acetone. So A and B are basically phenol and acetone. That is the industrial method of preparation of phenol, that is by cumene hydroperoxide method. Next is AgCl is soluble in aqueous ammonia. What is the complex? So that is very simple. That is your Tollens reagent. Complex is AgNH3 whole twice Cl, or we can just write AgNH3 whole 2 plus. Okay, that is a didentate, coordination number is 2 for this, and it's a linear complex, sp hybridized. Now HFO2, O3, F2, water, SF6 and CH4, they are asking you isoelectronic species. It's the same number of electron. Now if you see HF will have, hydrogen has 1 electron and fluorine has 9, so it is total of 10 electron. If it is O2, so it is 8 into 2, that is 16 electron. It is O3 means 8 into 3, that is 24 electron. F2 means 9 into 2, 18 electron. Water, that is hydrogen is 2 into 1 plus oxygen is 8, that is 10 electron. Okay, if we see methane, it is only, carbon is 6 plus 4, 10 electron, methane. And SF6 has a lot of electron in that, because fluorine has 9 into 6 plus sulfur is 16, so it is 54 plus 16, that is 70 electron. Okay, so the isoelectronic species are basically HF, then it is H2O, and then it is methane. These all are having same electron, so these are isoelectronic species. Next, the electron deficient species are, so B2H6 is one of the electron deficient species, which is having incomplete octet. Then BCl3, 6 electron, it is electron deficient. That's all. pH3 is having lone pair, so it is electron rich. NaH is Na plus H minus, that H minus is electron rich. So the correct answer should be B2H6 and BCl3 for this. Okay, let's move to next one. It is based on cyanide process, gold plus NaCN plus O2. So it will form the complex of gold with the cyanide ligand, that is Au CN all twice minus. Gold should be in +1 oxidation state here. After that, when this complex is treated with zinc, since zinc has more affinity towards cyanide, so now zinc will form complex with cyanide with the coordination number 4, and this Au will be precipitated out. So the complex A is this one. This is the complex A and this is the complex B. Okay. Next, phenol plus dilute HNO3. With concentrated HNO3 we get mainly oxidized product and picric acid. With dilute we'll get O-nitrophenol and P-nitrophenol. And we know that due to intramolecular hydrogen bonding, this is a steam volatile, very low boiling point. A and B can be separated by, so for a steam volatile species we do a steam distillation. So it is separated by steam distillation. Next. Okay, for this species, if we are treating with this bulky base, what is the product? So we know that whenever there is bulky base, it is Hoffman elimination product. So let's see. This bulky base will be removing this H plus and then it will be undergoing A2 elimination. So it is a type of E2 elimination and the product is this, that is 2-methyl propene. That is the final product. Next, among the following strongest oxidizing agent is, so chromium 3 plus is not a good oxidizer because chromium 2 plus wants to go to chromium 3 plus. For this E0 cell is positive because it has 3D3 half filled T2G, it is more stable. So chromium 3 plus will not act as a good oxidizer. Oxidizing agent will be Mn3 plus and iron 3 plus. Chromium 2 plus is a good reducing agent. Now they are asking the strongest oxidizing agent. So you must remember one order that has been asked many times in NEET, JEE and even advanced, that is E0 of M3 plus to M2 plus value is maximum for cobalt 3 plus followed by manganese 3 plus and then iron 3 plus. Okay. So cobalt 3 plus is the most oxidizing in nature, more powerful oxidizing agent, but that is not in the option. Then we will select the Mn3 plus. And one of the reason is because Mn3 plus after taking electron, it will become Mn2 plus that has half filled, D subcell, and due to that it is more stable. And Mn3 plus will act as a good oxidizing agent. Now electrophile in the Riemann-Tiemann reaction is, so that is very simple. In Riemann-Tiemann reaction, we treat phenol, okay, with chloroform and KOH. We take chloroform and KOH, basically 3 equivalent of KOH is needed, and we get salicylaldehyde as the product. O-salicylaldehyde is the major product simply because of this intramolecular hydrogen bonding. In this intermediate is basically dichlorocarbene that can be generated by treating this chloroform with KOH. This H and this Cl will get removed and it will be forming this dichlorocarbene which has 6 electron, and this is the electrophile in this case. Next, find the temperature at equilibrium for this. So we know that whenever a reaction is at equilibrium, delta G is equal to 0, and we know the relation between delta G, delta H and delta S, that is delta G equal to delta H minus T delta S. If this is 0, then delta H will be equal to T delta S, and temperature will be simply delta H by delta S. Okay. So now we just need to divide the delta H value, that is 165 into 1000 will do, because this is kilojoule, and divided by 550. Okay, so let's figure it out. It is 16500 divided by 55, and we are getting exactly 300 Kelvin. Okay, so that's the final answer for this. Now ethylene dichloride, we have to write the IUPAC name. Ethylene dichloride structure is this one, CH3CHClCl. So it is the parent chain 1 and 2. So we can just write 1 comma 1 dichloro ethane. That is what 1 comma 1 dichloroethane. That is the IUPAC name for ethylene dichloride.